And it comes from the thing I just told you, because the point lies above the real axis. So that's the real line. That's end of axis, we call it the imaginary number. It's not really an imaginary number, it's still a number, an actual figure. But we call it imaginary because mathematicians describe that line as a real line. So, what is this line? A line which is not real, so they just name it as imaginary. But it's not numbers that you create like that out of imagination, they are still numbers on the grid, okay? They're just unreal numbers. So what is unreal? Imaginary. So they name it imaginary number. So a complex number is here on that grid. So it consists of a movement from the point here on the real axis. So A units you move, and then you move B units there. So that's how you form the complex number, which is a movement. And we said it represents a two-dimensional variable.
So it's a real number plus an imaginary.
Plus an imaginary number.
So we don't put the BI in the imaginary.
So actually every single number on Earth is a complex number.
Exactly. Because if you say...
Say 10. It's actually 10 plus 0i.
Exactly. If you say number 10, that's a real number, but it's still a complex number. Because I can write it, like Stefan said, 10 plus 0i. So what can we deduce here? Real numbers are elements of complex numbers. So everything is complex. Every single number is a complex number.
Life is complex.
What are we going to think of?
You know, all your friends you used to be able to relate to you when it came to maths, now they're going to be like, oh yeah, Ian the maths nerd.
You walk around and say, countless school. Well, there is 5. There could be this. Wow.
Now, you could say why we have A plus BI. Because you need to differentiate between these two dimensions. We can't say A plus B. Because they have to include the I to tell you that, okay, that's another dimension. So I is as if a scale. So BI means moving B units on the imaginary axis. So they had to say it's another axis, so that's why they had to put a reference, so the reference is I there. Okay, so that's how complex numbers was formed. Okay, if you go on the link, they put a photo frame. Give you a photo frame here. Okay, describe as a complex number, then you can take your mouse, you click on it, you rotate it and all that, then it tells you what happens to the complex number. Okay, what are the parameters after you rotate, after you send it here, or send it there, like that. Okay, so you get to understand how it works on the complex number when you study these graphics. Okay, that's fine. So that's an introduction to complex.
So when it goes, so the point Z is under the real line, just becomes A minus BI.
A plus BI, it can be anywhere now.
Where it's under the real line.
That's the real axis. That's the imaginary axis. That can be here, it can be there, it can be here.
So it just becomes negative BI. That's it.
Yeah, depending where it is.
Okay.
This point here, that it should be a combination of a real number A and
Negative BI.
negative B, so Z is a negative BI. Okay? So that's complex number 4. I'm just going to show you how we add and subtract complex numbers for today. The last section. Okay, if I need to add these two complex numbers, you know that the complex number is written as a plus bi, so that's one complex number with complex number z1. You're adding it to another complex number z2. So you need to add these two complex numbers. Now, you know from basic maths that when you need to add terms in an equation, you usually add like terms together. It's the same thing here. So what I'm going to do is, I'm going to do 5 plus 2, so I add the real part, plus I add the imaginary part. So it's simply 7 plus 4i, that's it.
That's it?
Yeah, that's it.
Does it go harder?
It does.
Costs.
I mean this section. I mean this
Costs of complex numbers.
No, I mean this section. I mean.
In fact, you do have a section where you describe a complex number in trig form. Of course, because if you notice when we were messing around with the diagrams, it formed a triangle.
Yeah.
So you can have trig. You can describe it using trig.
So is that everything for this lesson?
We'll do one more example. Okay? Okay, what if we subtract? Okay, it's simply
Same thing.
9 minus 4 plus
Negative.
negative 2i, but
Plus 7.
negative, so 9, which is 7, plus 7.
I
9
did
minus
put
4 plus negative 2i plus 7i, which gives
5 plus 5.
5 plus 5.
It's the fine.
That's it.
That reminds me.